This is a sea level problem, and you'll see why this is a sea level problem. This problem requires two variables to get started. So I have a fence, and I've used 160 yards to build this fence. It's a rectangular fence, and I've got three parallel pieces of the fence, and I'm representing those lengths by X. So the Parkhursts have used 160 yards of fencing to enclose a rectangular corral, and they've divided it into two parts by a fence that's parallel to one of the shorter sides. So here I've drawn my rectangle, and then I've just come back and I've given it an additional piece to put the corral into two separate pieces, and all three of the parallel sides are the same length. So we're asked to find the dimensions of the corral if its area is 1,000 yards squared. So just thinking of, kind of thinking about the perimeter formula, but we have to adjust it a little bit. I have 3 x's, so I'm letting the horizontal dimension be represented by y. And if I have 3 x's plus 2y, that gives me the 160 yards of fencing. So what I have to do is solve this equation right here. I'm going to choose to solve it for y, so that I simply have an expression left with only the variable x in it. So on the way to doing that, subtract 3x from both sides. And now I need to multiply by 1/2. And when I simplify that, I get y equals 80 minus 3/2 x. Now if I think of my area formula, area is length times width. I could let the width be represented by x, and I could let the length be represented by this y right here. So I'm going to call this my length. So now I have an area of 1,000, and I have one dimension of w, and I'm going to let's stay with the x's. I'll let one dimension be x, and then the other dimension will be represented by the expression and multiplying this out. And you can see that I have a fractional coefficient on my quadratic term. I'm going to go ahead and arrange this in a quadratic form. And now to eliminate the fraction, I'm going to multiply everything by this denominator of 2. So I'm going to multiply each term by 2 over 1. And when I do that, here's my scratch paper, which we'll leave out of the way for a minute. When I multiply each expression by the red 2 over 1, I now have this to work with. And I can see that I lost a 0 here. That's 80x. So I now have this quadratic to factor, and I'm going to leave it up to you to finish the problem. The key piece of this problem is expressing both dimensions just using a single variable. And I'll have another one in class made up so you can get some more practice with this. But I've done the hard part of the problem for you, and I will ask you to take it from here to find the x value that works in the problem.